Hello. Okay, so today we're going to look at the sine and cosine ratio, a continuation of our previous lesson that we've been learning on the trigonometric ratio. If you remember, I mentioned of having three, we close this, having, not, we have more, but we are learning about the only three ratios: the tangent ratio, the sine ratio, and then the cosine ratio. And then we did the tangent ratio already. So today we're looking at the sine and then the cosine. We are looking at it together. So that is what we are looking at today. So if you look here, you could see a right triangle here. A right triangle here. So it have the opposite, the adjacent, and then the hypotenuse. I told you that the hypotenuse is always identified by looking at the right angle, the 90 degrees. And then the line which is opposite to that 90 degrees is the hypotenuse. So in this case, AB is the hypotenuse because this is the 90 degrees at C. So AB is the hypotenuse. The opposite and the adjacent depends on the reference angle. Which angle are you talking of? Which angle are you talking of? That is where we can determine the opposite and then the adjacent. So in this case, we could see that we are talking about angle A, which is over here. We are talking of angle A. So if you are talking of angle A, then our opposite is going to be BC, which is here. And then our adjacent is going to be AC, which is here. If we were to talk of angle B, if you are talking of this angle B, then our opposite is going to be over here, and then our adjacent is going to be over here. The hypotenuse doesn't change. It always stays the same, and it is always the longest side of the triangle. It's always the longest side of the triangle. So that is it. We'll come to this. You'll get to know this later on. This is the ratio that we are going to use. So if you remember when we were doing this, I mentioned of SOHCAHTOA. I mentioned of this SOHCAHTOA, this acronym, and then we did the tan. So you remember that we said that tan is equal to opposite over adjacent. That was what we did previously. Today we are looking at sine and then cos. Sine and then cos. So sine is opposite over hypotenuse, the ratio of the opposite of the triangle to the hypotenuse. But remember always that the opposite depends on the angle you are talking about. And then cosine, which is cos, is adjacent over hypotenuse. So that is what I had here. Sine is opposite over hypotenuse. Cos is adjacent over hypotenuse. So you can look at this example over here. So if you have triangle ABC, and this is our 90 degrees, we know that this is our hypotenuse. Our hypotenuse is here. This is the angle we are talking of. So our opposite to be at BC, and then our adjacent to be AC. So if you are looking for sine, which is opposite hypotenuse, so sine A is opposite over hypotenuse. Sine A is opposite over hypotenuse. And then cos A is going to be adjacent over hypotenuse. Our adjacent over hypotenuse. So that is what you need to do. The first thing you need to always do if you have any type of work that you're supposed to find a sine or cos, you look out for the opposite side. You look out for the hypotenuse side. You look out for the adjacent side. And you remember your SOHCAHTOA. So is opposite hypotenuse for sine, and K is adjacent hypotenuse for cos. So all you do is identify them and then put them in. Let's look at an example over here. So let's see this triangle. Triangle ABC. Triangle ABC with sizes AC 3, AB 5, and then BC 4. So we have AC is 3, AB is 5, and then BC is 4. This is our 90 degrees, so our hypotenuse is 5. And then if you are talking of angle A, where I use the red marker for, then BC becomes our opposite and AC becomes of our adjacent. If you are talking of angle B, where I've used the blue marker for, then BC becomes our adjacent and then AC becomes our opposite. Our hypotenuse always stay the same. Our hypotenuse always stay the same, in which this case is going to be AB. AB. So now we're going to look for sine A, sine B, and then sine sine A, sine B, cos A, cos B. That is what we are going to look out for. So you remember our acronym. So we put it here. Sine is opposite hypotenuse, cos is adjacent hypotenuse. So sine A. So we're talking of this angle. Use the red pen. So A is here. So our opposite is over here, which is going to be 4. So you're going to have 4 out of our hypotenuse, which is 5. Which is 5. Which is 5. Let's look at cos A. We're still looking at this angle. I've skipped this. We go to the B. We're still looking at this angle. Cos is what? Adjacent over. What is the adjacent? 3. So you get 3. Hypotenuse is still 5. Hypotenuse is still 5. So now, oh sorry, this is for cos A. I wrote that cos sine B. So we're talking about cos A. Opposite is 4, adjacent is 3, hypotenuse is 5, and then cos is adjacent hypotenuse. Adjacent hypotenuse K. So adjacent is 3 over hypotenuse, which is 5. So sine B, meaning we're now talking of this angle. Our hypotenuse always stay the same, but our adjacent and opposite are going to change because the angle have also changed. We're talking of this angle, so 3 becomes our opposite, AC becomes our opposite, and then BC becomes our adjacent. So sine B is going to be opposite over hypotenuse, which is going to be 3 over 5. It's going to be 3 over 5. And then cos B is going to be adjacent over hypotenuse, which is going to be 4 over 5. That will be for cos B. Cos B. So that is what you get. That is what you get. But if you look at it, you could see that sine A is equal to cos B. Sine A is equal to cos B. We're not doing like advanced trigonometry, so but that is something that is true. Sine A is equal to cos B, because you could see sine A is 4 over 5, cos B is 4 over 5. And then sine B is also equal to cos A. Cos A. Yeah, you apply it in some day, but not in this lesson. So that is how it is. So now let me give you one example for you to try your hands on, and then we move on. Yeah, we move on. So let's have this right triangle over here. Sorry. Sorry, my right triangle is not that perfect. This is our 90, but if you see the 90, it tells you it's a right triangle. Let's call here M, let's call here N, and let's call here L. And then say MN is 5, ML is 12, and then NL is 13. L is 13. So we're looking for sine L, cos L, sine N, and then cos N. So try your hands on this. Just pause the video, try your hands on it, and then after you've tried your hands on it, play the video and see if you got it right. If you got it right. So now compare your answer to this one and see if it was right. So we're looking for, let's look for the L first. So L is here. So if this is our L, then here is going to be our opposite, and here is going to be our adjacent. The hypotenuse is always the same. This is the 90, so here becomes our hypotenuse. So sine is what? So sine is opposite over hypotenuse. Opposite over hypotenuse. So sine L is going to give us 5 over 12. What about cos L? What about cos L? Ka adjacent over hypotenuse. So cos L is going to, oh sorry, 13. Sorry for this mistake. Is opposite over hypotenuse. So opposite this, the hypotenuse is 13, not 12. 12 is adjacent. So sine L is 5 over 13. What about cos L? Adjacent over hypotenuse. Ka. Adjacent is 12, hypotenuse is 13. So we have 12 out of 13. Now we look at N. So if you are talking of N, here becomes our opposite and here becomes our adjacent. The hypotenuse always stayed the same. So sine N is going to give us opposite over hypotenuse. Opposite over hypotenuse, which is going to be 12 out of 13. And then cos N is going to give us what? Adjacent over hypotenuse, which is 5 out of 13. Out of 13. So that is it. I don't know if you got this, that is good. But if you did not get it, I hope by now you've seen the correction. You saw where your mistake was. You saw where your mistake was. So now we're going to continue to evaluate some of these trig ratio. To evaluate some of them. If you remember when we did the term, we used it to find the angle, and then we use it to find some of the sides, and then we find the inverse sine. Is the same thing, just that this time we are not using tan, we are using either cos or sine. We are using either cos or sine. But I told you that anytime you are working with this, make sure that your calculator is on degree. By default, calculators are set to radian, but you have to bring it to degree. If you keep it at radian, then after your calculation you need to like convert it to degree, because we are working in degrees, not in radian. So this is going to be simple, just as you did last time. So let's see if you have what is going to be sine 42? Let me change this color. Sine 42. And then let's say cos 68. Let's say cos 68. So just put in your calculator. Just press sine, and then press 42. Make sure your calculator is in degree. So sine 42 is equal to 0.6691. I said always try to keep it to like 4 decimal places. And then cos, you just place cos, and then 68. Cos 68 is 0.3746. So that is also cos 68. Some of the calculators you wouldn't see 0 point, but you see point. So if you see the point, then you know it is 0 point. At times students tend to overlook the point and then just say maybe 6691, which is wrong. So the point should be there, and it is 0.6691. 0.6691. But what if you have the sine, and then we don't know the angle? We don't know the angle. So let's say if I have sine, just as you did with the 10, I hope you remember, if not forgotten. So you have sine theta is equal to, let's say, 0.4771. How do I find theta? How do I find theta? If you remember, sine inverse of that, because the calculation is simple, just using your algebra, which is going to be theta is equal to, I did it with a 10, so sine inverse of 0.4771, and then you put it in your calculator. What would be the sine inverse of 0.4771? Put in the calculator, enter, and then you're going to get your theta is 28.4962 degrees. You should know that it is in degrees, so you add degrees to it. So that is how you'll be able to find the angle if you are given the value of the ratio. You know that we're getting this to be from opposite over the hypotenuse. So it is the same way if you have, let's say, now this is in way, if you have something like, oh my gosh, this is too bad. This is not perfect, but let's take it later. This is 90 degrees over here. And then let's say we're talking of this angle A. And then this is 3. And then this is 5. This is 3, this is 5. We want to know the value of this angle. What is the degree of this angle? We know that if you are talking of this angle, this is opposite, this is hypotenuse. You know? This is opposite, this is hypotenuse. So we have sine, because it is only sine that talk of opposite over hypotenuse. So only sine that talk of opposite over hypotenuse. So sine, let's call this angle theta. Sine theta is equal to opposite over hypotenuse. So opposite is 3, hypotenuse is 5, which is equal to sine theta. So your theta is equal to sine inverse of 3 over 5. So you just put it in your calculator, and then you know how to put sine inverse, second function, and then sine. And then you see your sine inverse will come up. And then 3 divided by 5. You enter. And then, so our theta is 36.8699. So running it to the whole number, our theta is 37 degrees. To the whole number, our theta is 37 degrees. So you see, you can now find the angle. You can now find the angle. And then you can also find the side. We've not done the side, but you can also find the side using the ratios, just as we did with the tan. And it is the same way for cos. It's the same way for cos too. So let's say cos theta. Cos theta is equal to 0.7225. So what is theta? So theta is equal to cos inverse of 0.7225. And then if you put that in your calculator, you're going to get 44 degrees. So theta is equal to 44 degrees. 44 degrees. The same way, if you have a triangle, like this, these are 90 degrees. Let's say this is 5, and then this is 4, and you're talking of this angle. You want to know this angle. What is the angle of this? So you know that if you are talking of this angle, then this is going to be adjacent and this is going to be hypotenuse. So if it is adjacent and hypotenuse, then it is cos. Adjacent, cos, adjacent, hypotenuse. So if it's adjacent and hypotenuse, then it is cos. So if this angle is called theta, going to get cos theta is equal to adjacent over hypotenuse. Our adjacent here is 4, our hypotenuse is 5, which is equal to cos theta. So our theta is equal to the cos inverse of 4 over 5. And then you put it in your calculator. Second function, cos 4 divided by 5. Second function, cos 4 divided by 5. And then that gives you 36.8699, which is equal to 37 degrees. Which is equal to 37 degrees. So you see, it works and it is perfect. If you see what I did for the sine, it was the same thing. It was the same thing I used. So this is what I did for the sine. 5, 3, and then here will be 4. So I did here to be 4. And then you can use Pythagoras theorem to know that if this side is 3, this side will be 4, and this side will be 5. That is why we are having the angle to be 37 when I use sine, and then we have it to be 37 when I use cos. I have it to be 37 too when I used cos. Because using Pythagoras theory, we're going to get 5 squared is equal to 4 squared if this is our x plus x squared. And then this is going to give us 25 is equal to 16 plus x squared. So if you subtract 16 from both sides, you're going to get 9 is equal to x squared. And then if you find the square root of both sides, then so here will be 3. That is why when I calculated with cos, I got 37. I got 37 when I calculated with sine. So it's the same thing. So you can use any of them to work it. And then if you remember your Pythagoras theorem too, that one too will help you. That one too will help you. Pythagoras theorem will also help you work very well. Okay, let me give you some examples to work on. So evaluate, find. If you say evaluate, solve, find, they are all telling you the same thing. It seems my pencil is faint now. Let me see. Okay, I got it. Why? I need to, yeah. So find sine 60 degrees. So 1, sine 60 degrees. 2, sine 30. We are not doing any proof here because like you can use the Pythagoras theorem and then it's very simple, but I just want you to understand we are not doing any proofs here. And then cos 45 degrees, this of 2 degrees. And then what would be the, and then find the angle, find the angle, find the angle. Sine theta is equal to 0.4384. And then cos theta is equal to 0.2079. Okay, so I want you to do this one. I'm not going to solve it, but do it. But we're going to look at, okay, I think I'll leave this for another day where we can work more example with it, and then we'll look at solving with both of them. So I think this is, so just do these questions, and then let's see what we do next time. So next time we are going to solve more example, especially putting it in real life situation, and then giving practical example how you can calculate it. And then you realize that there are so many industries that needs this theory, they need this calculation. Think of some of them next time we'll look at it. So this will be the end for today.